Welcome everyone. In this video, we'll look at the oxidation of a compound that contains two alcohol functional groups. It's an A-level chemistry exam question. Details are in the description. Let's get started. Here's the first part of the question. Propane 1,2-diol has the structure CH2OH-CH-OH-CH3. It is used to make polyesters and is one of the main substances in electronic cigarettes. A sample of propane 1,2-diol was refluxed with a large excess of potassium dichromate 6 and sulfuric acid. Draw the skeletal formula of propane 1,2-diol. The first part of the name, prop, indicates that there are 3 carbon atoms in the longest chain. Ol tells us that the alcohol OH functional group is present. Di means that there are 2 OH functional groups present. 1,2 indicates the position of the OH groups. I've shown the displayed formula of the molecule here and numbered the carbon atoms. This will help you to link the name to the structure. The skeletal formula is shown in blue. Skeletal formula is a shorthand that has the advantage of showing the shape of organic molecules. Carbon atoms are shown with ends and bends. Carbon makes 4 bonds in stable organic molecules. If a carbon appears to be making fewer than 4 bonds, we assume that the remaining bonds are to hydrogen atoms. Hydrogen is shown as a H if it is part of a functional group. Atoms other than carbon and hydrogen are shown with their chemical symbol. Here's the next part of the question. Write an equation for this oxidation reaction of propane 1,2-diol under reflux using O in square brackets to represent the oxidizing agents. Show the displayed formula of the organic product. Alcohols can be classified as primary, secondary or tertiary. This depends on how many hydrogen atoms the COH carbon is bonded to. If the COH carbon is bonded to 2 hydrogen atoms, the OH group is classified as primary. If the COH carbon is bonded to 1 hydrogen atom, the OH group is classified as secondary. And finally, if the COH carbon is not bonded to any hydrogen atoms, the OH group is classified as tertiary. Primary, secondary and tertiary alcohols react differently. There are plenty of marks available for students who know the reagents and conditions associated with the organic transformations on their specification. Under these conditions, primary alcohols will make carboxylic acids, secondary alcohols will make ketones, and tertiary alcohols do not react. The general structure of these functional groups is shown on the right. Aldehydes can also be formed by primary alcohols, but a distillation is required rather than a reflux. We will look at this later in the video. The alcohol functional group highlighted green is primary. The one highlighted blue is secondary. Let's address the question. First of all, we can write out the organic reactants and product with the reaction arrow in the centre. There are 3 carbon atoms in a chain in the organic reactants, and this does not change in the product. The alcohol functional groups become a ketone and a carboxylic acid. It is a good idea to check that each carbon atom is making 4 bonds in any structures that you suggest. The question specifically states that the displayed formula should be used to show the organic product. This means that every atom and every bond must be shown. Balance for hydrogen atoms using water. Oxygen from the oxidizing agent is shown with an O in square brackets. The completed balance equation is shown in blue. Here's the next part of the question. Draw a label diagram to show how you would set up apparatus for refluxing. Draw diagrams with a sharp pencil and ensure that they are large and clear. Reflux is the continual boiling and condensing of a reaction mixture. Ensure that there are no gaps between the round bottom flask and the condenser. Any gases that are formed would escape if this fitting is not tight. A bung or thermometer is not present at the top of the condenser. This would lead to a build-up of pressure and would be dangerous. It is essential that you label water in at the bottom of the condenser and out at the top. Here's the next part of the question. Anti-bumping granules are placed in the flask when refluxing. suggest why these granules prevent bumping. Bubbles form when liquids boil. Large bubbles can bump around in the round bottom flask, and this could be dangerous. Anti-bumping granules are porous and inert. They absorb and release small bubbles before they become too large. The organic liquid product can be poured into another vessel, leaving the anti-bumping granules behind at the end of the reflux. To address the question, anti-bumping granules prevent the formation of large bubbles. And here's the final part of the question. Draw the structure of a different organic product formed when the acidified potassium dichromate 6 is not in excess. A milder oxidation reaction will occur under these conditions. If we want a milder oxidation reaction to occur, we would normally carry this out using a distillation rather than reflux. Primary alcohols can form aldehydes under these conditions, and secondary alcohols might not react at all. To address this part of the question, we can suggest any combination of the functional groups formed from the milder oxidation. Any one of the four structures shown in blue is an acceptable answer. The suggestions on the left-hand side show that an aldehyde functional group has been formed rather than a carboxylic acid. The top left suggestion and the suggestions on the right-hand side show that one of the alcohol functional groups has not been oxidized. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your exams.